Surds. I know that you probably already know how to deal with the square and cubic roots, and you also know specific terms of those subjects. But it is always good to remember. A radical refers to a number written as shown below. This symbol is a radical sign. This number is called index. This number is called radicand. The radical symbol and index show which root is being determined. The radicand is the number under the radical symbol. Any number written with the radical sign is called radical. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. A number is irrational if we cannot express it in exact form using decimals or fractions. In some problems, when the calculations to be undertaken involve irrational values and the answer is required in the exact form, we must write it as an irrational radical. An irrational radical is called a surd. In other words, a surd is an irrational number written as radicals or roots. Look at the examples. You can think of a surd as a more accurate way to write an irrational number. Otherwise, when written in decimal form, would go on forever without repeating. An answer in a surd form must be written in the simplest form. So we will see how to simplify surds. Simplifying surds. Surds are written in their simplest form when the smallest possible whole number is under the radical sign. There is no surd in the denominator. Essentially, there are three fundamental rules in surds. Rows of surds. The nth root of x raised to the power of n is equal to x. The square root of 7 raised to the power of 2 is equal to 7. The fourth root of 5 raised to the power of 4 is equal to 5. When multiplying surds, the numbers can be placed under the one radical sign. In plain English, the multiplication of roots is the same as the root of a multiplication. This rule is useful to simplify surds. Let's take the square root of 8. Our aim is to leave the smallest possible number inside the square root. 8 is the same as 4 times 2. We rewrite square root of 8 as the square root of 4 times the square root of 2. Square root of 8 is 2 times the square root of 2, or 2 root 2. The cube root of 3 times the cube root of 18 is the same as the cube root of 3 times 18. 18 is 2 times 9. 3 times 9 is 27, and the cube root of 27 is 3. Therefore, the cube root of 3 times the cube root of 18 is 3 times the cube root of 2. When we divide two surds, we simply divide the numbers under the radical sign and simplify the result. Let's split the radical containing a fraction into a fraction containing radicals. 50 is 2 times 25. The square root of 25 is 5, and the square root of 9 is 3. The result is 5 times root of 2 divided by 3. The square root of 2000 divided by the square root of 50 is the same as the square root of 2000 divided by 50. 2000 over 50 is 40, and 40 is 4 times 10. Therefore, the square root of 2000 divided by the square root of 50 is 2 times the square root of 10, or 2 root of 10. Express the following in the simplest possible form. The square root of 27 is the square root of 3 times the square root of 9. Therefore, square root of 27 is equal to 3 times the square root of 3. When we have to do roots of large numbers, we write the number as a product of prime factors and group them into pairs or according to the root we want to calculate. To simplify the square root of 986, we write 986 as a product of prime factors. We group the factors into pairs. The square root of 986 is the same as 4 times the square root of 6. The square root of 21 divided by square root of 7 is the square root of 91 divided by 7. So the square root of 21 divided by square root of 7 is the square root of 3. The cube root of 4 times the cube root of 16 is the cube root of 4 times 16. 16 is 4 times 4. The cube root of 4 times 16 is the cube root of 4 cubed. Therefore, the cube root of 4 times the cube root of 16 is equal to 4. Adding or subtracting radicals is the same concept as that of adding or subtracting like terms. We can only add or subtract radicals when the indices and the radicands are the same. Treat surds like algebra and treat each surd like a different algebraic term. 7 square root of 5 plus 2 square root of 5 plus 3 square root of 8 is the same as 7x plus 2x plus 3y. We can only add like terms, so this expression is 9x plus 3y. Therefore, 7 square root of 5 plus 2 square root of 5 plus 3 square root of 8 is equal to 9 square root of 5 plus 3 square root of 8. When dealing with expressions involving surds, it may happen that we are dealing with surds that are unlike, but which can be simplified to produce like surds. Thus, we should simplify the surds first and then look for like surds to add or subtract. First of all, simplify the square root of 27 and the square root of 45. After simplifying, we rearrange the like radicals to subtract 3 square root of 3 and 7 square root of 3, and add 2 square root of 5 and 3 square root of 5. Rationalizing denominators. Rationalize the denominator is the process of removing surds from the denominator. A fraction whose denominator is a surd can be simplified by making the denominator rational, although in practice we make the denominator a whole number. Rationalizing the denominator often takes the three following forms. If the denominator has just one term that is a surd in the square root form, the denominator can be rationalized by multiplying the numerator and denominator by that surd. Look at the example. The denominator can be rationalized by multiplying the numerator and denominator by square root of 6. Don't stop once you have rationalized the denominator. You should always check to see if, after the rationalization, there is something that can be simplified. Another example. The denominator can be rationalized by multiplying the numerator and denominator by square root of 20. If the denominator has just one term, that is a surd, and that surd is not a square root, the denominator can be rationalized by multiplying the numerator and denominator by that surd, but the exponent of the radicand is the index minus 1. Look at the example, 1 over the fourth root of 3. Let's multiply the numerator and denominator by the fourth root of 3 raised to the power of 4 minus 1. It's very simple. Another example, 21 over the cube root of 7. Multiply the numerator and denominator by the cube root of 7 raised to the power of 3 minus 1. Simplify. If the denominator of a fraction has two terms, swap the plus or minus sign and multiply the numerator and denominator by this expression. See the example. Multiply the numerator and denominator by 2 minus the square root of 3. At this point, we should remember the difference of two squares. When we expand the brackets in the denominator, we get the difference of two squares. So we have the term radical squared. Another example. Multiply the numerator and denominator by square root of 28 plus 3 times square root of 2.